Hi guys, this is a problem that you have in your packet that I gave you when we started these velocity and vector problems. So it's number 23, talking about a man rowing a boat. So very similar to the boy rowing a boat. Just want to point out a couple of different things. So this one will look very simple, but the process is the same. So the numbers here are easier, I think, but the process and the thought process is all the same. So what are we doing here? We have a man rowing a boat of velocity, speed of 1 meter per second in still water. He heads directly east across a river that flows south with a rate of 1 meter per second. So this time, we can think of our shores like this. He is proceeding, so he heads, so we'll make him red, and we'll make the water, make the water blue. That makes sense, I think. So he heads directly east across at 1 meter per second. And then the water is going to flow south and push him south at also 1 meter per second. Okay, so determine the magnitude and direction of his resultant velocity. So again, just like last time, velocity has magnitude and direction, and resultant, almost always think about it as the hypotenuse. So we're going to find the hypotenuse of this triangle here. Okay, so the hypotenuse, well, this one's really easy because c squared is going to be equal to a squared plus b squared, but we're only dealing with ones, so c squared equals 1 plus 1. So c squared is going to equal 2, take the square root. So c is going to be equal to square root of 2, so this is square root of 2. And if you put that in your calculator, you should have that c equals 1.41. So, or 1.41 meters per second. So far we know that we have the magnitude, check. We have the magnitude of his resultant velocity. What we're looking for now is the angle. So now remember, always start where he starts. He starts here. He starts out this way, and then he gets pushed in this direction. So what we're looking for is this angle right here. Okay? So we're going to look for that angle. Again, I encourage you to always use things that they gave you. Keeps you safe, just in case you made a calculation error. So if I'm looking at this angle, then this side here would be considered my opposite. This side here would be my adjacent. So I'm going to use TOA, or tan. Okay? So of SOHCAHTOA, I'm going to use tan. So tan of theta is equal to the opposite, which is 1, over the adjacent, which is 1. So then we do tan -1 of the quantity 1 over 1 is equal to theta. And if you put that in your calculator, you will see that theta equals 45 degrees. Okay, so what have we figured out here? Well, let's just put it onto a cleaner slide. So we have this. Here's our shores. We have our guy. He's going across at 1 meter per second. The water is pushing him this way, 1 meter per second. And we found that his resultant velocity, so velocity, is equal to 1.41 meters per second. That's the magnitude. He started off east, so east, 45 degrees south. So that would be the answer to A, magnitude and direction of his resultant velocity. Now, let's take a look at B. That the river is 10 kilometers wide. So just keep in mind that our velocity was given in meters per second, so be very careful. Oh, sorry, I should include his velocity, not the river's. It was given in meters per second, so just watch your units and make sure that you're doing appropriate conversions. So if we have 10 kilometers, you could say that that is 10,000 meters. And we're going to use our formula that velocity equals displacement over time. We have our velocity. It is 1. That is going to be equal to the distance he needs to travel, 10 kilometers or that many meters. And then time, so then to solve for that, what's going to happen is that we're going to bring the t up here, so t then is equal to 10,000 seconds, okay, because it's in meters per second. So 10,000 seconds is how long it's going to take him. Of course, you could say that 60 seconds is 1 minute, 60 minutes is 1 hour, and convert that to hours or minutes. It just might be more reasonable that way. If you do convert it to hours, it's about 2.78 hours that it takes him to get across. So that's what happens when you work at 1 meter per second, I guess. So it's going to take him about 2.78 hours to cross. Now, in the previous problem, I said, you should find the distance that he travels across in order to figure out the time it takes. The time it takes doesn't really matter if you're going to look at the distance on the hypotenuse or the distance across the top, as long as you match the distance with the right velocity. For instance, if I'm going straight across here, I don't want to use the velocity that was the hypotenuse here, okay? You want to make sure that you're using the distance and the velocity from the same point on the triangle. So, yes, you could definitely use the hypotenuse. However, you will get the same answer by using what's given and the velocity for that segment. Do not, however, use the velocity for that segment on the hypotenuse or vice versa, okay? So let's move on then, and we're going to look at part B, I guess number 2, the actual distance he travels. So this is going to be important to consider that hypotenuse, okay? So we had him moving this way, and the river's flowing this way, okay? Now, the actual distance he travels. So we have a time now, right? We said that he's taking 2.78 hours or 10,000 seconds. So we have a time, okay? We had a velocity. Now we're looking at the resultant here, okay? So we have a velocity for that. Resultant velocity was all the way back here. We found out that he's working at 1.41 or moving at 1.41 meters per second. So that's back from part A. So we know that he's working at 1.41 meters per second. We know that the time is 10,000 seconds. And so we have everything we need to determine the displacement. So V equals displacement over time. The V we have is 1.41 is equal to displacement, which we're trying to find, and time. I went back to seconds because this is meters per second, so I don't want to do any more conversions. So you can do that, no problem. Just go back to the seconds. No matter what unit you choose, just make sure it's consistent. You don't want to have seconds and hours in the same equation. Okay, so if you do that math, you will find that he, if you do that math, you will find that he has traveled, I made a mess here, goes back in, 1.41 meters per second. So if you do that math, you find out that he has gone 14100 meters, or 14.1 kilometers. Okay, so that's what he's gone along here, 14.1 kilometers. Okay, so that's along the hypotenuse. That's how long he's actually traveled. Now, of course, this is only 10 kilometers wide, but he's actually had to travel this distance because of the movement off the path he was hoping to be on. Speaking of the path he was hoping to be on, we have how far downstream from his starting point will he land. So let's take a look. Here's our shores again. Here's our guy. Here's the water. We know this distance, okay, we just found it. We found it to be 14.1 kilometers. We know this distance across the top is 10 kilometers. When you have two sides of a right triangle, you can use Pythagorean theorem to find the third side, and that's in fact what we want to do. We want to find how far off is he course. How far off course is he? Of course, he started here. He tried to end up here, but he actually ended up here. So what is that difference? How far off is he? So 14.1 squared is equal to 10 squared plus b squared. Of course, you could also use the angle measure and do SOHCAHTOA if that's better for you. Pythagorean's good too. So let's put that in our calculator. Okay, so you find then that b squared is equal to 98.81. square root, v is equal to 9.94, and of course that is in kilometers because we used kilometers here. So he actually arrives 9.94 kilometers off course from where he wants to be. So to summarize, let's just do and look at the two triangles. So the first triangle we looked at was a velocity one, where he was moving at 1 meter per second and the water was moving at 1 meter per second. Then his resultant velocity, or the hypotenuse, of course I don't remember what that was, is 1.41 meters per second. 1.41 meters per second. And then we also found that this angle that he traveled at, so this angle here, was 45 degrees. So his velocity was 1.41 meters per second. He started off going east, 45 degrees off course, then headed south. So that would all be the velocity stuff. Now talking about the displacement. That triangle, 10 kilometers across. And then we had also found the hypotenuse to be 14.1 kilometers. And then we found finally the distance off course was 9.94 kilometers. And so those are all distances, okay? So remember, notice, these are all velocities. These are all distances. Never do they mix. But the link between these two triangles is that v equals displacement over time.